project is on heart failure identification using EKG signals and machine learning. So some background information. The heart orchestrates the circulation of blood throughout the body. It operates in two crucial phases. During diastolic, the heart is at rest, it'll fill with blood. And then systolic, when the heart contracts and it propels blood outward. These phases are regulated by an electrical impulse, and then which initiated an SI node, and then it will travel throughout. And the SI node is the housing pacemaker cell that generates action potential, and action potential will travel throughout the heart. And an echocardiogram, an ECG or an EKG, serves as a device that's capable of detecting the electrical activities, and it offers a valuable means to assess and monitor heart health, particularly in identifying conditions such as congestive heart failure. The main objective of our project is to develop a predictive model for classification of congestive heart failure using ECG data. And the significance is a classifying model can be used in diagnosis of heart health, and this will aid in early detection in congestive heart failure.
And we ended up using two data sets for this project. The first one was the BIDMC congestive heart failure database, taken from physionet.org. And that included EKG recordings from 15 subjects who all had severe congestive heart failure in classes 3 to 4, which is the severe part of it. Recordings were about 20 hours long for each patient, and you can see a sample in the left side. And the second database that we used was the MIT BIH normal sinus rhythm database, also accessed from physionet.org. And that included EKG recordings from 18 subjects who were found to not have any significant arrhythmias or heart issues. Those recordings are about 25 hours long each, and that's also a sample. The methodology for the project was, first thing was to load the raw data from CHF and NSR data folders that we accessed from Physionet. Then we had to extract the EKG signal from .dat files using Physionet's data storage algorithm. And we had to process the data, which that was in 2 steps. We had to make reasonably sized data samples. And for that, we only extracted 8 seconds long from each EKG signal, just so that we wouldn't have to analyze all 20 hours or so. And since we only had a limited number of patients in each study, we had to increase the number of samples. And we did that by extracting 3 random snapshots of each EKG signal. And each one of those snapshots was the 8-second long. Next, we analyzed those signals using a scalegram. And scalegram is made by doing a continuous wavelet transform on the signal, which plots frequency intensities as a function of time. So it's like a fast Fourier transform, but as a function of time. Then we exported those scalegrams as .jpeg images. And next, we moved on to training our neural net. We split the set of images into training data, validation data. Then we modified the existing GoogleNet infrastructure, and we trained the GoogleNet network on our images. Next, we performed validation using the validation set, and we tested it.
Okay, so the first thing we did was obviously we trained the model. So this is kind of an overview of the training process. At the end of that process, we had a validation accuracy of 80%. And then next, we wanted to make sure that the model was detecting things correctly. So in this step where we tested for accuracy, we used a confusion matrix. The 1 indicates congestive heart failure or CHF. 2 indicates normal sinus rhythm or NSR. And then we also calculated the trained model accuracy based on a set of test images that the model had never seen before. And so that is what this confusion matrix is also based on. Lastly, is our demo. So what the user gets to see is just selecting a .mat file. And after that, it will output a scalegram indicating which MAT file it chose, what the signal is that it converted from, as well as what the input file was and what the model classification was. And so here we indicate that it's able to do that correctly, and we'll do that live in a second. Okay. So here we just choose any old .mat file. Wait for it to go through the model. Okay, so this is a CHF file, chf.mat file, and what it's doing is it's choosing a random 8 seconds segment, showing us the image that it's taking from that, and then classifying it as CHF, as seen here.